Hello, welcome. My name's Dave Hicks, and we're going to learn some chemistry. I'm going to continue on with my acids and bases series. Today, we're going to finish this off with titration calculations. When we get done, I expect you to know what titrations involve, what they are, what they're used for, and I think you should be able to calculate the concentrations of acids and bases from the titration data. First, what is a titration? Well, a titration is a way that we try to figure out how much of an acid or a base is in a solution. We do it using a neutralization reaction, and we do this with what we call a standardized solution. A standardized solution is just either the acid or the base that we know what its molarity is, how much acid or base is in there. And then we do this reaction, do some stoichiometry to it, and try to figure out how much of the other substance there is. When we do this, we get to a point where we have to make it so that the moles of the hydrogen ions are equal to the moles of the hydroxide point. We call this the equivalence point. On there is a YouTube link. I don't know if you want to watch that one or not, but it's someone who actually does a titration in front of you, so you can see what it sort of looks like when one is done. One of these days, I may make one of those. But for right now, I'm going to show you how to do the calculations that surround this so that you'll be able to calculate what the molarity of either an acid or a base is. Now, what I'm going to show you is like a simplified version of this solution stoichiometry, because we're going to have two solutions, an acid and a base. One of them will know what the molarity is, what the concentration is, see? So either the acid will know what its molarity is, or the base will know what its molarity is. In either case, we'll know what the volume is for both of them. And then this right here, this little N with the hydrogen and N with the hydroxide, this stands for how many hydrogens and hydroxides are in that particular compound. Let's see, let me write out what each of these symbols are. So the M here stands for molarity. This is the concentration, or how much stuff is in there. And then the V here stands for a volume. Now, this volume could be in milliliters or liters. It doesn't matter which. It could be in quarts, gallons. It doesn't matter, but it could be in either one of these. Typically, it's in milliliters. The N here is representing the number of hydrogens in the particular formula. So like if I had like HCl, there'd only be one hydrogen in there. But if I had H2SO4, then there'd be two hydrogens that's a part of it. Likewise over here, same thing for this, but over here for this one, this is how many hydroxides are in the formula. So if it was NaOH, then there'd just be one, but if it's like Mg, magnesium hydroxide, then there'd be two of those, and we'd put a 2 there. All right, so let's see, what have I got down here? Some more terms about a titration. One question might be, when you're doing this, I mean, this is something we do in lab, how do you know when the number of moles and the number of acid and base are equal to each other? We use what's known as an indicator. And an indicator is something that changes colors when it's in either the presence of an acid or a base. And so as we cross the neutralization line, these indicators will change to a different color. And that's what we're looking for, is the change in color that takes place. When this color changes, we call that an endpoint. Endpoint, that's when the color changes from one to another. That lets us know that neutralization has been accomplished. Okay, here's an example titration problem, and oops, I think I got one in the way here. Here's an example problem for us, and it says that we're going to find the molarity of a sample of hydrochloric acid, and we're going to neutralize it with a 0.1 molar sodium hydroxide solution. And so you can see here that I started with 25 milliliters of the hydrochloric acid solution, and I used 20 milliliters of the base. Now the base is our standardized solution. That means we know what the molarity of the base is. Again, in this case, we know both of the volumes. You should always know that. And we are looking in this case for the molarity of the hydrochloric acid. So let's bring our equation back out here. There's the equation we're going to live by. So in this case, I have hydrochloric acid, HCl, and I see there's only one hydrogen in that. So this number right here, the N for the hydrogens, the number of hydrogen units that it's in it, is just 1. So I'll put that 1 there. The molarity for the acid, that's what we're looking for, right? And then the volume for the acid we see here is 25 milliliters. Again, we can work in any unit that we want to for the volume, because it should just cancel out on both sides as long as it's the same. On the other side, how many hydroxides are in it? Well, here's sodium hydroxide. You can see there's only one hydroxide, so that's just going to be 1. The molarity here is 0.1. That's something that was given to us in our problem, so we can put that in there. And then the volume that we used was 20 milliliters. So if you do some fancy algebra here, hopefully you can do this. It should work out to be, I'm only going to do the algebra once here, but this should work out. If I collect everything up, I should have 25m is equal to 1 times 0.1 times 20. That should be 2. So divide both sides by 25. And I get that my molarity is 0.080 molar. Not sure if my sig figs are really correct on that, but that's how you do it. All right, well that was pretty simple. But what if we have something that has a little more complexity to it here? So I'm going to go and pull this example out of our way and put another one up for us. So here it says, in a titration of sulfuric acid with potassium hydroxide, 18 milliliters of a base were required to neutralize 10 milliliters of a 0.25 molar sulfuric acid solution. What's the molarity of the potassium hydroxide? All right, again, working from our formula here, I'm looking at this and I'm seeing that right there is my sulfuric acid, and you see that 2 right there? That's the 2 I'm referring to. So this is saying that there are 2 hydrogen ions in 1 unit of this sulfuric acid. So in this case, this one's going to be 2. The molarity, that was given to us, 0.25 molar for the acid. And then my volume says to neutralize, it says it neutralized 10 milliliters. So I'm assuming that this is going to be 10. On the other side, potassium hydroxide, just 1 OH in it. The molarity says, what is the molarity of this? So that's the one we're looking for. Like I said, you're either going to be searching for the molarity of the acid or the molarity of the base. That's the purpose of a titration. And it says that we used 18 milliliters of the base to neutralize it. So I'll put that in there. Again, quick, do your algebra. I'm not going to work through it this time, but you can. And what you should have gotten is that the molarity is equal to 0.28 molar hydroxide. All right then. As usual, I have one here for you to work on. Let me put this up. And why don't you give this one a try? Press that pause button, work it out, and when you're ready, I'll be right here to check your work. All right, how did you do? Well, if you followed this formula right here, I bet you did just fine. So let's check this out. How many hydrogen ions? Looks like there's just one. It says that we're looking for the molarity of the acid. I'll put that back up. And the volume, we started out with 30 milliliters of that. Base, there's two of them here. Molarity, they gave that to us. It's 2 molar. And the volume of this one is 60 milliliters. Again, work out that algebra. Molarity here, I got, are you ready? 8 molar. Yeah, that's what I got too. All right, so that's that. I hope you got to see a couple of good examples on how to do the calculations that are associated with titrations. I wish you good luck, and I hope to see you again. Have fun with your chemistry.